Section 12.2, what we're dealing with in this section are systems of linear equations, and what we're going to do with these systems of linear equations is put them into matrices. So what exactly is a matrice? Well, a matrix or a matrice is defined as a rectangular array of numbers, and here we have this rectangular array of numbers. We'd have a number here, number here, number here, and so on, and then number, 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 so on down the column. So here we have columns, and across we have rows. Down runs the columns, across runs the rows. Each number aij of the matrix has two indices. The row index is I, so this first number usually signifies what row it's in. This would be first row, second row, ith row, mth row, first row, second row, first row, second row. The second number refers to what column it is. So something like A22, that doesn't mean it's the 22nd thing in the matrix. It just means it's in row 2, column 2, row 2, column 1, row 2, column J, and so on. This one has m rows and n columns, and so the numbers, all these are just referred to the entries as the entries of a matrix. So A23 would refer to the entry in the second row, third column. It's not like the 23rd thing, it just means second row, third column is what that stands for. So how are these going to help us? Well, what we're going to do is we're going to take a system of equations, a system of linear equations, and we're going to put them into a matrix. So the matrix is used to represent a system of linear equations, and it's called an augmented matrix. The variables must be on the left side of the equal sign and the constants on the right hand of the equal sign. A variable that does not appear has a coefficient of 0. So here the number in front of this x is a 1, and then 4 goes 4, 14 goes there. Usually you put a line there, kind of like the equals. The 3 goes there, the -2 goes there. Keep in mind the sign in front of the number is going to get stuck with it, and then over here we have 0, and the 0 goes down there. So what a matrix does in terms of linear equations is we can kind of forget about the variables and look at just the numbers, and even with just those numbers we're going to be able to solve this system of equations. So if we wanted to look at this system of equations and write an augmented matrix, the first thing we have to make sure is that we have the constants over here and then the variables over here. So this first equation, 2x minus y, you could think of that as minus 1y plus 1z is equal to 0. And the second one would be 1x. There's 0 y's, so we do plus 0 y, and plus 1z is equal, this constant, this minus 1, has to get moved to the other side, and when it gets moved to the other side it would be a plus 1. This last one, here we have 1x, which comes from right there, plus 2 y's, and then plus 0 z's is equal, this minus 8 again is going to have to get moved to the other side as a plus 8. Notice how all the x's are in a row, all the y's and all the z's, and the constants are all in a row. So then when we take this and put it into augmented matrix form, we just look at the coefficients, -2, -1, 1. The line that we put down there usually represents the equals and 0. And then we have 1, 0, 1 equals 1. That's the second one. And then the third one is 1, 2, 0, 8. Would be that one right there. So that's the augmented matrix. If we instead have an augmented matrix and we're going to put the linear equations in there, this is just like the column x, this is the column y, and this is z. So you could almost just do 2x plus 5y minus 1z is equal to 2. And that's exactly what it is. 2x plus 5y minus z, usually we don't put the 1 in front, is equal to 2. The second one, x plus 3y plus 2z is equal to 17. This third one, x plus 2y plus 3z is equal to a minus 1. This would be the system right here. Usually you see a squiggly bracket, but usually this is the system of linear equations that corresponds to the augmented matrix. Now, row operations. Row operations are on a matrix are used to solve the systems of equations. So when we do a row operation, that's what we're doing to try to solve the system of equations. There are three basic row operations. We can interchange any two rows. We can replace a row by a non-zero multiple of that row. Or we can replace a row by the sum of that row and a constant non-zero multiple of some other row. What do these things mean? Well, for example, let's say you have the following augmented matrix. So up here we have the matrix right here, and then what we're trying to do is we want to solve for this. So we want the 4 to become a 0, and I'll explain a little bit more why later on, but we want this 4 to become a 0. And kind of like elimination, when we did this with just elimination and the actual equations, what we're going to do, we're going to take row 1, that's this whole row right here. So we're going to take the row 1, which is 1, 2, and 3, the little line. We're going to take that and we're going to multiply it by -4. When we do that, what it becomes is -4. This -4 is going to have to distribute to all the pieces. So -8 and then -12. Then we're going to add the rows together. So we're going to add this first row that we took times a constant multiple, and we're going to add it on to the second row for -1, 2. When we add those together, notice how that becomes 0. This becomes -9, and this becomes -10. And so when we do this operation right here, that bottom row becomes 0, -9, -10, which is that right there. The way we show this, we show R2, so we took R2. This is the row that was changing. R2 became this right here, and we did that via taking -4 times the first row and then adding it on to this second row. And that's what kind of this scratch work up here is for. The way again we show that is R2 became, you could think of equals or became, -4 times R1 plus R2. So let's practice. It says find and perform a row operation that will result in the augmented matrix to have a 0 in row 1, column 2. So row 1, that's this one right here. Column 2 is this one right here. This number here is what we're trying to have a 0 in. What the directions say to get a 0 in. Well, how could we get a 0 here? If we added this to this, so this 2 to this -2, we would have 0. So what we're going to do, we are going to replace R1, and we're going to replace R1 with R1 plus R2. And that would result in a 0 in there. Now if we did that, if we replace R1 with R2, so we got to add these two together, because R1 plus R2, so row 1 plus row 2, 1 plus -4 would be -3. -2 plus 2 is 0. 4 plus 3 is 7. And then the second row just stays the same. Well, find and perform row operation that will result in the augmented matrix to have a 0 in row 1. So do we have a 0 in row 1, column 2? Yes, we do. This part right here, this is the actual row operation we did. We did R1 plus R2. Something called row echelon form is, when you look at this, down this diagonal, notice how there's 1s. Over here in kind of this triangle portion, we have 0s, and it doesn't really matter what numbers we have here. So this right here is row echelon form to have 1 down the diagonal, 0s in this triangle right here. In terms of what these directions are saying, the entry in row 1, so that's this entry here, column 1 is a 1, that's true for row echelon form, and only has zeros below it. So when I look at this one here, it should only have zeros below it. The first non-entry in each row after the first row is a 1, only zeros appear below it, and 1 appears to the right of the first non-zero entry in any row above. So got to be careful what I'm hitting here. So only zeros appear below it. So here we have a 0 below it. The 1 appears, this one right here. What that's saying is this one right here appears to the right of the first non-zero. So that's to the right of this non-zero entry in any row above it. And any rows that contain all zeros to the left of the vertical bar up here at the bottom. So if we did have a row that had all zeros, we would just put it down there. So this one right here, this would be row echelon form. We have 1s down the diagonal, and everything below a 1 is 0. So again, if you have 1s down the diagonal and everything below it is a 0, that would be row echelon. Now in this case, this row echelon form, what is this going to tell us? Well, keep in mind this first column represented x and then y. So this 1 right here would be a 1x. This is saying in our system of equations, x plus 0y or plus nothing is equal to 5. The second one here is telling us this is our y's, no x's, so no x's and y is equal to -1. This right here tells us that our solution to whatever the system started as, so there were a bunch of ones probably before this, but whatever was before this, that system of equations has a solution of 5, -1. Let's take a look at another one here. This example right here, this is row echelon form, so we have 1, 1, here's a 0, but that's okay because below the 1s we have zeros. This tells us these are x, y, and z's. So what this tells us is the x is going to be 0. This one here is the y. The y is going to equal 0. But what does this tell us? This tells us there are 0 z's. So this is saying 0 is equal to 2. Not true. This one right here, what this means, when we get something like this is not true, this is inconsistent. That's what this one tells us. This one right here, what does this one tell us? Again, we have x's, y's, and z's. We have 1s down the diagonal or the 0 in the end. That's okay because below the 1s are zeros. So below the 1s are zeros. This is row echelon form. And what does this actually tell us? Right here, this 1 would be x plus the 4z is equal to 4. That's what this first tells us. The second one tells us that 1y plus 3z's is equal to 2. Notice how here z is 0, but 0 is equal to 0. This is true. This means, because we lost that z variable down there, this means that there are actually infinitely many solutions. And so they're going to be of the form, well, in terms of z, depending what we would pick z to be, they're going to be a form x is equal to -4z plus 4. So solving for the x, here we have -4z plus 4, and y is equal to -3z plus 2. The answers, the infinitely many solutions, are going to be in this solution right here. So depending what we pick, z determines x and it determines y, and it determines it based off of these equations right up there. So let's suppose we're going to practice with this. Let's say we're going to solve this system of linear equations using matrices. Well, before I can have you do that, there's one additional piece of information you need to know. And that's what's called reduced row echelon form. So if possible, what we want to do is get the echelon form, this right here, the form that we were working with, and we want to get it down to where there's ones across the diagonal, zeros below, and zeros above. When you have ones down the diagonal, zeros below, and 0 above, that's called reduced row echelon form. And the reason that's so helpful is because we can just look at these variables right here and know exactly what they're equal to without having to do anything else. So let's go back to this set of system of equations that we had. If I put this into a matrix, we would have 2x plus 1y plus no z's, so I use a placeholder, is equal to -4. Then there's 0 x's here, minus 2y's, and 4z's is equal to 0. This last one, there are 3 x's, 0 y's, -2z's, and is equal to -11. So what are we going to do to try to solve this one here? Well, one of the first things I would do is, it's nice to try to get this diagonal in terms of a 1. So I'm going to start working here, and when I start working here, then I'm going to try to get zeros below it. Then I'll focus on this, zeros below it, then I'll focus on the last one. So I'm going to start focusing on this. I'm going to try to get that as a 1. What do I have to do to make this a 1? I'm going to have to change row 1 by multiplying it by a half. And when I do that, I'll get 1, 1/2, 0, and -2. The other ones are just going to stay the same. So 3, 0, -2, -11. Well, now what do I want to do? I got this a 1. Now I want to focus on getting zeros below this. To get a 0 below this, this right here would have to be a 0. In order to do that, I'm going to take, this is row 3, so I'm going to take row 3, and I'm going to replace it by row 3 plus a -3 times row 1. Because if I take this times -3, add it on to this, I'll get a 0 there, and that's what I'm shooting for. So when I do that, I'm going to have the same thing in row 1, 1, 1/2, 0, and -2, and 0, -2, 4, 0. Now this, I'm taking this plus -3 of this, so that becomes 0. I also have to take this plus -3 times this. Well, -3 times a half is -3/2. This -2 plus 3 or plus -3 of this, -2 plus -3 of times 0 is just going to be -2. And then here, -11 plus 3 plus -3 times -2. That's -11 plus 6, so that's -5. I got this a 1, zeros below it, that's what I was shooting for. The next thing I'm going to focus is making this become a -1. So to do that, I am going to take row 2 and replace it with -1/2 times row 2. The first row is going to stay the same, 1/2, 0, and -2. The second row, -1/2 times 0 is still 0. -1/2 times -2 is 1. Negative 1/2 times 4 is minus 2. Negative 1/2 times 0 is 0. And then 0, negative 3/2, negative 2, negative 5. Like that. From here, what I'm going to do, I'm going to focus on trying to get this a 0. So I got this a 1. Now below it, I want zeros. So to do that, I'm going to take R3 and I'm going to replace it with R3, that row, plus 1 times what would be negative 3/2? Well, that'd be, I'm going to have to add 3/2 of this to it. So I'm going to add 3/2 of row 2 onto row 3, and that's what I'm going to replace it with. Row 1 just stays the same, 1, 1/2, 0, negative 2, and then 0, 1, negative 2, 0, and then here 0 plus 3/2 of 0 is still 0. Here, negative 3/2 plus 3/2 of this is going to be 0. Negative 2, so if I do some scratch work, negative 2 plus 3/2 times negative 2. So negative 2 plus 3/2 of this, which is negative 2, those 2's minus 3, so that's going to be a minus 5. And then here, negative 5, so we're going to have negative 5 here, plus 3/2 of 0. Well, that's going to be negative 5 there too. Now, I got a 0 below this one, so the next thing I'm going to focus on is getting this to be a 1. So that I have 1s down the diagonal. To do that, I'm going to replace R3, row 3, with negative 1/5 times row 3. Because if I take negative 1/5 times this, I'll have a positive 1. So here, the first row stays the same. Second row stays the same. I'm not messing with that row. The third row, we have 0, 0. Negative 1/5 times this is 1. Negative 1/5 times this is 1. And there, I have row echelon form. Now what I want to do, I want to get this into reduced row echelon form. So I want zeros below the ones, but I also want zeros above the ones. Now that I've got all the zeros below and ones down here, I'm actually only about 2 steps away from being complete. So I want a 0 above here. To do that, I'm going to have to take row 2 and add on 2 of this right here. So 2 of row 3. And when I do that, all that's changing is row 2. So the first row stays the same. The second row is going to be changing. The third row stays the same. When I add 2 of row 3 to row 2, so adding 2 of these, still going to stay 0. 1 plus 2 of these, still staying 1. Negative 2 plus 2 of these is going to be 0. And 0 plus 2 of these becomes 2. Now, I have zeros above this. I still want a 0 above this one. So I'm going to have to change row 1. I'm going to change row 1 by taking row 1 minus 1/2 of row 2. Because if I subtracted half of this, I would get 0 there. And so, when I do that, we're going to have 1 minus half of this is still 1. 1/2 minus half of this is going to be 0. And 0 minus half of this is still 0. Negative 2 minus half of this would be like negative 2 minus 1. So that's going to be negative 3. Second row, we're not changing, 0, 1, 0, 2. Third row, not changing, 0, 0, 1, 1. Now I have this in reduced row echelon form. what this is so helpful is because I only have an x here, because this column corresponds to x, this one y, this one z. So I only have an x here. X is equal to -3. Right here, y is equal to 2. And z here is equal to 1. If I wanted to double check this, I can take these numbers. Let's say I used the last one, 3x minus 2z is equal to -11. Let's see if these numbers actually do work out. 3 times -3 minus 2 times 1. Well, this would be -9 minus 2, which is -11. And that's what we're shooting for. So all that work to get this solution right here that tells us the answer to all these. Now these numbers here, when you substitute them, I checked it with this one, but they should work in both of these too, and you can double check that if you want. This one was just more space in case I ran out. This one here, solve this system of linear equations using matrices. So this one here, this one here is just for some more practice. So I'm going to put this into an augmented matrix, 2, 1. Fortunately, all the x's, y's, and z's are already in place where they need to be. So then I'm just going to rewrite this, except with only the numbers, not the variables. 1, -7, 3, -4, -3, and 7. And so here, first thing I want to focus on this right here, getting this to be a 1. In order to do that, I'm going to have to replace row 1 by taking it times a half. So I'll replace row 1 with 1/2 times row 1. And when I do that, 1/2 of 2 is 1, 1/2 of 1 is 1/2, 1/2 of -3 is -3 halves, and 1/2 of 0 is 0. The other part, -2, 2, 1, -7, I didn't change anything else. So 3, -4, -3, 7, like that. Now I want to focus on getting zeros below this. So what I'm going to do, my next step in the process, I'm going to take row 2 and I'm going to replace it with row 2 plus 2 of these. So plus 2 of row 1. When I do that, the matrix that I get, I'm not changing the first row, so that's staying the same. 1, 1/2, -3 halves, and 0. Row 2, so this plus 2 of this is going to be 0. This plus 2 of this is going to be 3. This plus 2 of this is going to be -2, and this plus 2 of this is going to be -7. Row 3 is not changing at all, so that's just going to stay the same like that. And so far, we've done 2 steps. We have a 1 here, a 0 below it. I'm still looking to try to get one more 0 here. So I want this third row, I want there to be a 0 here. So I'm going to take row 3 and replace it with row 3 minus 3 of row 1. Because if I take 3 of these away, I'll have a 0 there. When I do that, the first row not changing, so that's staying the same. Second row not changing. I'm only changing the third row. The last row, I'm taking this minus 3 of this is going to be 0. -4 minus 3 times a half, or 3 halves. If I have 4 minus 3 halves, that is like 8 halves, so we're going to get 5 halves. -3 minus 3 of this, it's like -3 plus 9 halves. So -3 times this would be 9 halves. This is like -6 halves. So we're going to get 3 halves. And then 7 minus 3 of this is going to remain 7. And as I'm looking at this, I know there's a high probability of making mistakes, especially with these fractions. And so I've worked this out. This is probably actually my third time working this out. So I notice already I made mistakes. And so if you have to try multiple times, the easiest is to actually just start from scratch and then see if you can figure out where you went wrong. So here, this row 3, so -4 minus 3 of this, so minus 3 halves, we'd have -8 halves minus 3 halves is going to be -11 halves. Here, -3 minus 3, or so minus 3 of this, well, that's really -3 minus 3 times -3 halves. I'm going to need a bottom of a half, so I'm going to use -6 halves plus 9 halves, and that's going to give me 3 halves, like that there. And then here, 7 minus 3 of this still remains 7. So I'm just, as I'm looking at this, I'm double checking my work that I've done previously. Now I have this 1, zeros below it. The next thing I'm going to focus on is getting this to be a 1. What do I have to do that? I'm going to take row 2 and I'm going to replace it with 1/3 of row 2. When I do that, first row isn't changing, 1, 1/2, -3 halves, and 0. Second row, 0. Third of this is 1. Third of this is -2/3, and a third of this is -1. And then below it, 0, -11 halves, 3 halves, and 7. Next thing I'm focusing on, I've got this a 1. I'm going to focus on getting zeros below it. To do that, I'm going to have to replace row 3 with row 3 plus 11 halves of this right here. So that's 11 halves of row 2. So row 1, not changing. A lot of this is just copying down the parts. So you want to try to be very accurate when you're copying. Second row, not changing. We're changing row 3, so the second row stays the same. -1. And the last row, we're taking this plus 11 halves of this, so that's still going to stay 0. This plus 11 halves is going to become 0. This, which is 3 halves, plus 11 halves of this, which 11 halves of -2/3 is 3 halves minus 22/6. Well, this is going to have to be 9/6. So 9 minus 22 is -13/6. And then what are we doing? We're doing row 3, so 7 plus 11 halves of this. So 11 halves times -1. This is going to have to be halves, so 14 halves minus 11/2, which is 3 halves. And again, I'm going to check the work off to the side that I've already done to see if this is looking right. And of course it's not. So here, again, why isn't this looking right? This is not looking right because, and it's not looking right because if I backtrack here, like I was saying, copying is important. here I went from a -7 to a -3. That wasn't right. So that's going to throw this off, which is going to throw this work off, which is going to throw this right off here. So if I go back here, let's see here, get the pen. So this I should have copied this as -7, which meant when I took this row times a third, this would have been -7 halves. And now what am I trying to do here? I'm trying to take row 3, which is 7. So it's the 7 plus 11 halves of this. So times -7 over 2, which I'm going to see, I can see I need a bottom of 4. And of course I'm still messing up. Getting a little bit too tired apparently. So here, I screwed that up, and right. So this here took a third of this, so this is -7 thirds. So we're taking row 3, which is this, plus 11 halves of this, which is going to look like that. I'm going to need a denominator of 6, so I'm going to do 42 over 6. That would be 6 times 7 is 42. Correct? Yes, I got to double check now even my simple math. Minus 77 over 6. Well, this is going to be -35 over 6, and that's what I get right here, -35 over 6, like that. Now this next thing, I'm going to want this to be a 1, so what I'm going to do, I'm going to replace row 3 with -6 13ths row 3, because if I multiply this by the reciprocal, then I'll end up getting a 1 there. And what happens when I do that, and give myself a little bit more space here, nothing's changing with row 1, that's staying the same. Row 2, nothing's changing there, because I'm just changing row 3. And the last row, 0 times -6 13ths, 0 times -6 13ths. This times the reciprocal is going to be a 1. And then -6 13ths times -35 6. So those are going to cancel out. Those are going to go to be a positive. This is going to be 35 13ths. I'm going to take this here and I'm going to copy it onto the next slide. And now I have reduced or echelon form, so I've got zeros below the ones. I'm going to try to get zeros up here. I'm going to start with this one. So I got zeros here, then here. Now I'm going to start focusing on this here. So what I want to do, I want to replace row 2 with row 2 plus 2/3 row 3. And so first row not changing, that's staying the same. -3 halves and then 0. The second row is getting, so this second row here, we're adding 2/3 of this row. 0 plus 2/3 is still 0. 1 plus 2/3 of this, still 1. -2/3 plus 2/3 of this is going to be 0. And then -7/3, so do some work off to the side again, -7/3 plus 2/3 of this, 35 13ths, is going to be, if I do this longhand, so I can see I need a multiple of 13 here. 7 times 13 is 91, so negative 91 over 39 plus 70 over 39. This is going to be negative 21 over 39, which I see a 3 comes out of top and bottom, negative 7 over 13. And fortunately, at least some stuff simplified, and the bottom stays the same, 35 over 13. Nothing else, you'll get excellent practice with your fractions doing something like this. So then keep going. I want a 0 above this, so I'm going to take row 1 and replace it with row 1 plus 3 halves row 3. Row 1 is changing this time. We're doing this plus 3 halves of this is still going to be 1. This plus 3 halves of this still going to be negative 1/2. This plus 3 halves of this is going to be 0, and 0 plus 3 halves times, or 3 halves of this, so 35/13 is going to be, I don't see anything that simplifies this time, so 35 times 3 would be 90, 105/26. So we're going to get 105/26, and row 1 was the only one that's changing. Row 2 staying the same, negative 7/13. Here I'm seeing another mistake already. So I had this extra little scratch that I thought was a minus, but it's not. So I better make sure I get rid of that so I don't mix myself up even more. And the last row, 0, 0, 1, 35 over 13. Then I want to get rid of this, so I want this 1/2 to be 0. So I'm going to take row 1 and replace it with row 1 minus 1/2 row 2, because if I subtract half of this, I'll get a 0 there. So again, row 1 is getting replaced, so I'm taking this minus half of this is still 1. This minus half of this is going to be 0. This minus half of this is still 0. 105, so some more work off to the side. 105 over 26 minus 1/2 of this, negative 7 over 13. So 105 over 26 plus 7 over 26, which is 112 over 26. That should simplify because they're both even. So I see this as 56 over 13. Second row is not changing, 0, 1, 0, negative 7 over 13. Last row, 0, 0, 1, 35 over 13. The good news is we're finally done. We have 1 zeros below it, 1 0 above and below, 0, 0, 1. So now we can take this. All that work was to say that x is going to have to equal 56 over 13. Y is going to have to equal negative 7 over 13. And z is going to be 35 over 13. Yes, do realize that these can take a lot of work, but by simplifying it so that we're only using the coefficients out front at least saves us some of the headache. And what this set of solutions should do, it should work in this set of equations over here. So, sometimes I am actually tempted to sleep on these matrices when I'm having trouble. Good luck!